Hello students, it is class 11th, subject chemistry. The topic is anomalous behavior of lithium. You know that lithium belongs to alkali metals. It is a member of alkali metals, or we call it group first. Okay, so this is in fact the second element of alkali metals after hydrogen. It has all the characteristic properties of alkali metals. However, it differs in many respects from alkali metals. The reasons for which you are aware of, maybe it is because of its small atomic and ionic size. The size of its atoms and size of when we were discussing physical properties, atomic properties, we have seen that its atoms are as well as ions are small in the group. Number one. Number two is it is high ionization enthalpy. Its ionization enthalpy is highest in the group. Ionization enthalpy, which means that the energy required to remove the last electron from outermost shell, and that's called ionization enthalpy. And here in this case, a great amount of energy is required compared to other elements of the group. This also depends upon the size of atom directly. Okay, so then we have another, that is least electropositive. It is least electropositive in the group. Least electropositive. This is the least electropositive matter in the group. What is electropositive? Electropositive means that electropositive means ease with which an atom of an element loses electron. So it has lesser tendency to lose electrons. This is again because of its high ionization enthalpy. This is again because of its small atomic and ionic size. Okay. Then another difference is that it has no vacant d orbitals. There are no d orbitals in it, since it belongs to second period. Second period elements do not have d orbitals. So these are the four characteristics of this lithium, which makes it different, which makes its properties different from the elements of from other elements of the group. So let us come to its properties. First is it is hardest of all alkali metals. It is hardest of all alkali metals. It means that all alkali metals are softer than this lithium. Okay. Then we have second property by which it is different from other elements is that it is less reactive than other. It is less reactive. It is less reactive than other elements, other alkali metals. Okay. So it is less reactive. We have seen that when we place these in open air, they get tarnished, even some explode like sodium by reacting with this moisture, by reacting with oxygen of the air. But this is not tarnished because it is less reactive. Then we have another property is that its melting and boiling points are very high, MPs and BPs. Melting and boiling points of this lithium are higher than other elements, or higher than other elements of the group. Then we have another, it is lithium, it's chloride. Lithium chloride is deliquescent and crystallizes as hydrate. It is deliquescent and crystallizes as hydrate. Hydrate is LiCl twice water. But others do not crystallize as hydrate. Chlorides of other elements, we have sodium chloride, we have potassium chloride, they don't crystallize as hydrate. This is only lithium which crystallizes as hydrate. Then we have another property of lithium which is different from others is that lithium carbonate is not obtained in solid form. Lithium carbonate is not obtained is not obtained in solid form. This is not obtained while as the carbonates of other lithium, hydrogen, sodium, potassium, etc., rubidium, cesium, they are always in solid form. Okay, so this is another property by which it is different from other. Then we have sixth one, it forms monoxide, lithium monoxide, Li2, while others form peroxides and superoxides. For example, we have Na2O2, then we have others form superoxide. This is called sodium peroxide, and these are called metal superoxides. Metals peroxide and superoxides. The other elements form peroxide, superoxide, while lithium forms only monoxide. So in this way, it is different from other elements, okay, of the group. Then we have another property is that it is less ionic. The salts of lithium are less ionic than others. Less salts are less ionic. This is due to the smaller size and high polarizing power. Power of lithium ion. Since it is very small, the valence shell is nearer to the nucleus, so when it forms, for example, it forms lithium chloride. This is negative, this is positive. This ion attracts the electron cloud of this. As a result of this distinction into positive and negative ends of the molecule is reduced. So this electron cloud is attracted by lithium. As a result of this is not as ionic as the salts of other elements of the other elements of the group. Then we have another property by which is different. It forms lithium carbide and lithium silicide with carbon and with silicon. So it reacts with carbon to form lithium carbide and with silicon to form lithium silicide. While as other elements of the group, they don't react with carbon side to form silicides and carbides. Okay. Then we have another property by which it is different from the other elements of the group is that it does not react with acetylene to form acetylide. For example, we have seen that this is 9th.